Howdy, everybody in YouTube land. What we have in front of us today is yet another power supply. This one goes to an Apple Network server. Now, I don't know which one it goes to. I don't know if it's the ANS 500 or something like that, but some of those servers had dual power supply configurations and some of them had single power supply configurations. Well, this is the single power supply version, where this goes directly into the motherboard and it doesn't have the dual outputs that some of those machines had. I don't own any of those machines. The only thing I got here is the power supply, and it was sent in just like this. I don't have the rest of it, but I do know that it's a Delta Electronics DPS-300EB. That's the model of this power supply. Now, I believe, let me look at the letter here. Let's see. At any rate, before it died, I noticed I'd have to hit the soft power maybe a few times to get it to kick on. Now it won't power up at all. I have fully cleaned and recapped it. I have a feeling it has something to do with the soft power on electronics, but I have no idea what it could be. Can you take a look at this for me? Well, yes, I can. So, it was recapped. Unfortunately, it does not work. It didn't fix the problem, which I didn't figure it would. Sometimes a slow degradation to failure is caused by capacitors, right? Especially something of this era. But also, the next alarm bell is a slow degradation of a component, typically a resistor. Usually, if it goes from working and then suddenly not working, it's a semiconductor failure or something along those lines. But an intermittent, slow degrading operation till it just doesn't work anymore is typically the caps, which has already been taken care of, or the resistors. There's probably a resistor somewhere in here that does not, that went open. Now, the problem is where? Where do we start? Well, if we look at this design, we have this TOP200 circuit. So this is the standby regulator, further reinforced by the fact we have a 5-volt trickle output. So this is our signal going out to the motherboard that gives the CUDA chip power so we can turn the power supply on. And that ends up over here on this pin in the middle there. Number 11, or no, 13. Okay? Well, right next to number 13 is this gray wire, which you can just barely see. It's right there. We have a gray wire, which is number 12, I think. That goes all the way over here, which is the on-off signal. So, it's very similar to the ANS 500 dual power supply. Now, those have an interposer board that has some circuitry on it that allows the two power supplies to run together. And this one's not much different in that regard because we have a couple of sense wires here for tracking purposes. But anyways, so this is all a standalone setup from what I understand. But it's either A, we're missing standby voltage from this power supply here. There's an issue going on here. Or we have a problem over here where we're not getting the chip itself is not running, because we've got a support component for that chip that has died, or the chip itself has died. Because there's a UC, there's a 38, let's see, what is it? It is a 3843, which is fairly common. 1996. So yes, the 3843 is a fairly common chip. I've had to replace them before, but not like from a failure, just from a failure on my part anyways. But not from, an active failure. Usually they don't go intermittent like that. They either work or they don't, right? Anyway, so it's either one of the support components to that or that itself, or one of the resistors that feeds the power into this circuit has opened up. Because here's the thing. The switching side of this power supply requires a low voltage as well for all of these components to operate, right? As well as the 5 volts here. But here's the thing, the 5 volts from this doesn't go over here, because the primary and secondaries of the power supplies are isolated. They have to be. You got the hot side and the cold side. So if we flip this circuit board up, you can clearly see the isolation we got going on down here, even right down to the opto isolators. So if we look at this standby, we have our trickle right there. Well, there's our output. Well, if we follow it, it doesn't go anywhere into the primary. It's feeding the LED side, secondary side of the opto isolators, as well as the rest of this, right? So the on signal, which is like here, I think, flips on the opto isolators, right? So one of these is the enable, and we've got feedback and stuff like that. So this section, the primary section of the controller, needs power from somewhere. So if we follow the bridge rectifier, we've got two capacitors here, which form a voltage doubling network, and we've got a triac circuit and a controller and all that stuff. So this thing can support multiple input voltages, but it gives you like a voltage doubled output or something like that. Well, this is the negative side, or the ground side, because we got false ground here, but we got the negative there. But if you follow that, that's positive. So one ends up into the standby regulator, but if we follow it down, it ends up in the primary of the main switching transformer, but it also goes over here into the circuit here. If we follow it, it just kind of goes all over the place. So everything from this point needs to be chased through, right? If that's our problem, if it's not the standby voltage that's missing. And it's just 4 resistors. Now, I've already taken the liberty of checking these resistors and all the other little ones here, and they're fine. So it's not that. Now, usually, a slow degradation of failure that's not capacitor related is usually a resistor that's slowly drifting up in value until it gets to a certain point where it's not enough to sustain the operation of the power supply. Because what that is, it's a soft start or kick start circuit. So that provides a trickle voltage for this controller to run. And as soon as this power supply starts, the transformer has a rectifier that comes off of it, like this diode over here, that rectifies the output from another winding, and that takes over and keeps all of this stuff energized while it's on. That's usually how switching power supplies work. There's a resistor network, dropping network that feeds just enough voltage in to start this guy up for this feedback loop to take over. Once this transformer takes over, then that keeps everything energized, keeps the voltage on at all of these ICs and this circuit over here and all of that. That's how, in theory, that's how all of this stuff works. So what we got to do is, since this doesn't have the plug, we're missing, the plug here. So I've got to take this cord and wire it in so we can energize this power supply and we can see what's going on. It's either going to be a fault in here or it's going to be a fault over here. So we need to figure out which one it is first before we can proceed with the troubleshooting steps here. So the usual disclaimer applies. Do not go probing around a power supply and sticking your hands in here unless you really know what you're doing, because there can be voltages in here that can seriously hurt you and or kill you. And I will not be responsible for irresponsible decisions. Now that that is out of the way, if you don't know how to work on power supplies, I suggest you do a lot of reading and watching a lot of YouTube videos from people that do. That way you can be more careful, and you're careful around high voltages and stuff like that. I'm not saying this to scare you away. I'm just saying this to pay attention and be careful. All right. So I have my probe just kind of sitting in this 5-volt trickle signal, and I have my ground shoved into the ground probe, or ground point right here. We're going to plug the power in, and we're going to look at the meter. Nothing. So there's our problem. We are missing the 5-volt standby voltage. Now, we have this TOP200. I've seen these go bad quite often. Usually when they go bad, they fail shorted and they take out a resistor in between so the standby circuit doesn't work. Right? But since this was a slow failure, I've got to check everything in this standby supply, and I need to make sure we're getting primary voltage. Now what I could do is I could take this bench supply and I can feed 5 volts in here as well as 12 volts, because this has some other voltages that go out too. But that's not isolated, so that's dangerous. So again, goes back to my further point. The grounds, hot and cold grounds, are separate, so you can't, unless I have an isolation transformer, you can't do that. So I need to get in here with my probe and start checking primary voltages to make sure all of that is there or it won't work. Alright, so I measured these 2 points and I have 170 volts sitting here, but I've got nothing over here. Like I got 0 volts between one and one. I got like 13 millivolts between the others. So this board's not running. Now, I've not worked on one of these power supplies before, so I don't know if the 170 volts here is normal, right? Because you'd think, with the way this is configured, I should have double line. So it should be closer to 200 and something volts here. Maybe that's why this board's not running. Maybe not. I don't know. But this circuit here helps manage this. And it's probably not running. And it may not run until the power supply is signaled to come on. I don't know. But I got to start somewhere. And right now that somewhere is on this board here. So I'm going to check all the components on this board. And if everything is okay on this board, then I probably have to change this guy. Because these fail. Which means I have to order a part. And then check again. And if that doesn't work, then chances are my voltage here is too low. And I have to go back a stage and look over here. Matter of fact, I should probably check both of them out and make sure. So yeah, I'm going to go ahead and warm up my desoldering iron. And we are going to pull out both of these modules because we need to take a look at it. And before you do, make sure your primary voltage has been drained off before you work on this power supply. This has some drain off resistors. It will drain with time, but it does take a little bit of time. It takes a good 5 minutes for these 2 caps to fully drain. So keep that in mind as a safety thing. Alright, now that I got the 2 boards removed, we can take a closer look. Now this one, I just did a quick dry check of all the diodes and transistors and that big resistor there, and they're fine. Now these actually connect to these 2 pins over here. So they work together, hand in hand. So if that doesn't work, this doesn't work. So I haven't checked all the SMD resistors yet, but I checked all the other stuff and it's okay. Now, this board here is the standby board and it's very similar to the other Apple power supplies at the time. So when this TOP part shorts, it usually takes this 1 ohm resistor out with it. It blows it apart. Now, I just checked this one and it's fine. I also checked this one, which is a 47K, like a 3 watt or a 5 watt or something, and it's also fine. So, unless something has gone open or this IC itself just went bad, then yeah. So I'm going to have to go through the rest of these components on this board and check everything. And I will bring you back if I discover something. All the caps are new. I don't know what the original ones are, and I don't know if the owner had put the right ones in their place, but I can check everything else. And if everything else is okay, then chances are we've got a defective TOP part. But it didn't short, it probably just went open. Alright, so all the components check good on this board. So there's absolutely no reason why this thing should not be running, but it's not. So this thing produces multiple voltages. So we get a voltage over here that is regulated down to 5 volts with that regulator over there, and we get an output there. So we have that voltage there. But we also, that's on one of the secondaries here, right? So this is like a 12 volt or a 15 volt or some odd voltage output when it's stepped down to 5 volts through there. So we got 2 outputs there. But we have another secondary that goes off over there. So these 2 is what goes off to this board, which runs that circuit over here. Now, that is also an output voltage. It's coming off the other secondary, and there's a rectifier diode and a filter capacitor, and all of that tests fine as well. So there's at least 2 voltages, 3 voltages coming off of this board, right? So, and then there's another one right here, because there's another diode, D51, which is used somewhere as well, and it's going off over here. And there's another filter capacitor, so yet we have another voltage. So yes, that's also important. Actually, I'm wondering if that's a control signal. Turns it on and off. Never thought about that. Maybe that's why it's not running. Because I don't have the original system, but I can only guess. So I need to chase that down, but I don't think that's it. Because you go there. It runs down and around, and yeah, it does. It's part of this network. So, but it's entirely possible this is like a feedback signal. I don't know. I'll have to study the circuit some more. Alright, so I did some more studying. Get that out of the way. I did some more studying of this circuit board. So we've got a voltage that's produced. We got two voltages produced here for the cold side, the standby circuitry. This, these two here are a dedicated voltage that runs this. So if this is not running, that's not going to run. We've established that. Now this pin here, which is going to this transistor, I just followed the circuit. So there's another voltage that comes here that's used as a feedback and also runs the IC, right? And there's a resistor here that's part of the feedback network for setting the voltage. Well, that is going to this transistor on the emitter side. Base is connected to ground through this Zener diode, and a collector goes out here. Okay? So, what that tells me is this is just a Zener regulated series pass regulator. So, this is yet another voltage. So, we got two voltages being produced here. We got another voltage produced here, and we got another voltage produced here, which then feeds down here and helps part this. Okay, so this power supply is also handling the supply voltage for running all of this. So if this doesn't run, none of this is going to run, even if I substitute voltages on the cold side, because we have another voltage that comes down and it ties into this circuit. So we've got a voltage coming off the main supply going in, but we have another additional voltage coming in as well, which ends up all the way around here. I'm not sure which voltage is being used for what, but if this ain't running, nothing's going to run. So this thing should run all the time no matter what. There's no way to turn it on or off. And all of the resistors on this board and all the diodes and everything are checking okay. So that leaves one thing left. This guy here is defective. So we have to replace him before we can do any further troubleshooting. Unfortunately, this component is discontinued. So we're going to have to go old stock to find it, or find a compatible one. So, yep, it didn't fail short, but it did fail. Alright, so first thing we're going to start with is we're going to replace this and see if it comes alive. So now the parts have come in. I have the 226Y, which is a 75 watt part, and this, I've seen this used in like the 20th anniversary Macintosh power supply, or at least I've used these in there, and it works fine. But I also got this one too, which is more, it's a 15 watt, and it's more on par to what this is. So I figured, well, I'll try this one, see what happens, and if it doesn't work, then I can move to this one. So I went ahead and got both, and I got extras just so I have some spares on hand, because this is a common failure part, and I just want to have some on hand. Matter of fact, I've got a 20th anniversary Macintosh that quit working on me, and I think this is why. So we got that all taken care of. So here we go. I have the new one installed. The old one's over there. Well, let's hope like hell it works. Now, this is the resistor that usually blows apart when these short, but this wasn't shorted, and that's still good. So I'm hoping this chip just failed silently, and that's where the issue is, because this board would not run at all. And as long as this thing's getting voltage, this board should run 24/7. There's no way to turn it on and off. So that's got to be our issue. So we're going to replace that and then get this thing back in here and see what it does. Let's hope it works. Let's hope that's all that was wrong with this thing. Alright, so I got the board reinstalled, the new components in there, this one's put back in there. So we're all set up, ready to go. I got my plug ready to go. I got my probe and the ground point. I have my meter probe here. Let's make this quick. So here we go. Well, it drew power, but it did that before. Let's see, what do we got? Oh, yeah. There we go. There we go. So we now have 4.9 volts here. Let's see. 4.9 volts. 10.6. And this is on the cold side, which shares a different ground, so I can't check that. All right. The power supply standby is 100% operational. So now comes the fun part. So what I've got to do is I've got to get a crappy, let's see here. Purple is our trickle out, which is on, let's see how I want to do this. Let's see. Purple and white. White is our on-off signal. No. Over temperature protection. On-off is gray. So where's our gray? Okay, yeah, that's gray because white's in the middle. Alright, so that leaves us... These two signals have to be bridged together, I think. I'll have to play with that to get this power supply to run. But before I can do that, I need a load. So we've got a blue and we've got a red wire here. Let's see, where does blue go? Blue goes to, looks like 12 volts. Red is 5 volts. So we can hook a Molex connector there and plug a hard drive dummy load or something into it and fire this power supply up and see that it works. Hopefully it will. Hopefully that was our only problem. So this one was a silent failure. This little TOP-200Y, they don't make those anymore, and these are on the EOL list, but you can still get them as of the making of this video. But yeah, so this TOP-200Y was a problem. So it failed silently. There you go. That's a big thing with these. So, alright. So we know the 222 works, so I don't really need to, because there's the part number, if anybody wants it. So yeah, the 222 works fine in this power supply. So we're going to go ahead and get a load hooked up and try to figure out this connection, because I don't have the machine. An Apple Network Server is rare and expensive, so I don't have the machine, so we've got to simulate the loads. Alright, so here we go. Hard drive loads connected, everything's connected. I got a voltmeter hooked up on the 12 volt supply. So in theory, it should start as soon as I jump the trickle voltage over to the on signal. Well, that's a good sign and a bad sign. It's starting and then stopping, so... okay, so we're getting somewhere, but we're still not quite where we need to go. Now, if you remember, we have these sense negative and sense positive wires. I'm wondering if this thing is like the O2 power supply, where these sense wires have to be connected to their respective points on here, or it's not going to fire up. Which is, what color are those? Green and orange? Where are they? There they are, right there. So green and orange. So I've got a battery bombed board, so let me take a look on that real quick. Alright, so this board here is completely screwed. It's battery bombed, no good, not going to work. And there's our power connector. So it goes in like that. So we know those two wires are on the end, in the middle there. So if we look, yep, that very end pin is connected to the pin above it, which is ground. Now the pin next to it, it's not exactly clear where that one goes. But if I were to hazard a guess, it probably goes to the line above that one as well, which it doesn't appear to, so I'm not entirely certain on that one. So at least we know the negative lead goes to ground. So I got a jumper here. I made a couple of these, so we're going to take you, put you there, so you're now connected to ground. Now we're going to try to start you up again. Let's see what happens this time. Well, it's trying, but we're still not getting enough. So that means we got to figure out where this plus wire goes. That I'm not certain. So this power supply, and there's also a signal here, OTP, which I think is over temperature protection, but I'm not sure. Maybe there's got to be a voltage on this wire. I'm not 100% certain because I don't have a functional board. So I can't like probe around and see what this thing is doing. But the power supply is at least trying to start. Where the original owner complained that the power supply wouldn't even work at all, wouldn't even try. So we figured out what that was. That was our ultimate problem. But I want to get this thing to bench test, but I may not be able to. So I'm going to have to stab at this one for a little bit. Alright, so I've been over this thing a couple of times now. This definitely has to be grounded. That sense positive goes over to 3.3 volts through the resistor network that's there, along with the motherboard. There's 4 ohms between here and here on the motherboard. So I tried that. It's not really making any difference. And the problem with this design is, from what I can tell, the problem that I see is he recapped it, right? And I don't know if he used the right capacitors in the right spots. So I'm basically flying blind here. Chances are they're correct, but really, I don't know. So, yeah, there's something with the overcurrent protection. This over temperature protection is at 5 volts or 4.9 volts, which, again, I don't know if that's normal or not because this is the first one of these power supplies I've ever seen of this style. So, the only thing short of just plugging this in the battery bombed board and potentially blowing the whole works up is to just send it like that is. And I don't like doing that because I can't bench test it. It's not able to fire up. So it's something to do with this circuit down here. It's going into overcurrent protection because these are the sense wires for current consumption. So these are designed that if the power supply, if the circuitry, hard drives and all that stuff start pulling more current than this power supply can handle, it shuts it down. Which is why it's ticking like that, because it's not able to start because, well, it's starting, but then it's tripping the overcurrent feedback path, which is here in this op amp. Or, well, actually, that's not even op amp, that's a quad comparator. But yeah, it's literally tripping it. It'll trip, restart, trip, restart, because there's something up with how this works. And I'm not entirely certain what that is yet. But anyways, that's where we are. Oh, yeah, the other problem is this battery bombed Apple Network Server board, which is right here. The problem with this board is when I'm measuring, there's a short between 5 volts and ground. So 5 volt and ground is shorted somewhere on this board. It's 0 ohms. So even if I were to plug this board in, it's going to shut down anyways because the 5 volt is literally shorted to ground. So I am not 100% certain on how to approach this scenario. So I got to studying this a little bit more, and this is all I got. I didn't get the case or anything, just the board, right? So I did some more studying over here, and these are the fan connectors, and there's also sense return for the fans as well. So if that could be the other thing too, if it's not sensing fans plugged in here, or there's an issue with the fan, it's not going to run either. So a lot of it plays a part. Same thing with there's a temperature sensor there, which probably ramps the fans up as this gets hotter, right? But there's a feedback path that goes back that way. So if the fan draws excessive current or doesn't draw any current at all, it'll do the same thing. So yeah, I don't know. I don't have the right setup to test this thing properly, and I don't like that feeling because I like testing everything before I kick it out the door. But unfortunately, in this case, I can't do that. So, but without a load, the power supply voltages remain stable. All of my voltages are there, so I know the power supply will run. It's just our current sense circuit is tripping out super early because of just how this works and how that's set up. So unfortunately, it is what it is. But the original fault is this. I've already talked to the owner, and he said just send it back to me. I'll put it in the machine and I'll fully test it. He also said it was working perfectly fine until it just didn't turn on anymore with the standby circuit. And before it would, he'd have to hit the power key several times before eventually it would come on. So yeah, this is our issue right here. So that is why it failed. That has now been repaired. We have voltages. It's stable. I just can't test it under load. So, yep, it is what it is. So in the meantime, let's just go ahead and I want to take another stab at this a little bit more because I don't like giving up that easily. But I think I'm gonna have to because this is an issue. Also, I got to looking at this a bit closer. One thing I've noticed is we don't really have any load resistors on the output. I mean, we got a couple resistors here, like 100 ohms. There might be some load resistors here. I'm not sure, but I'm not seeing any good sized load resistors here, which is an issue because you need load resistors to keep the thing in feedback. So it's entirely possible that this one hard drive alone is not enough of a load to keep this thing running. So yeah, that could be the problem as well. So, and I don't have any good light bulbs or anything. Let's see, what do I have here? This is a 23Z9. That's not enough. So yeah, I don't really have a good load to keep this thing stable, because if I had a decent load for this power supply, it might start up and run, but I don't have one. Yeah, this sense positive wire is tied up to 3.3 volts using a 470k resistor, and then it comes down to a 30k resistor under this heatsink and into this quad comparator. So putting this at 3.3 volts doesn't do anything. Putting it at 0 doesn't do anything other than shut it down. If I remove it and it jumps up to 3.3 volts, it shuts down, and then you have to reset it. And if I put this to 5 volts, it just shuts down immediately, so or it won't start. So that's not what it is, because the 5 volts would trip the overvoltage protection, right? So I'm thinking this sense wire has to be somewhere between 0 and 3.3 volts, but neither one makes a difference. So the only thing that I can suspect at this point is I don't have enough load. But I know for a fact the sense negative is grounded for sure. But leaves the only wild card, which is this OTP. Maybe something has to be done with it. I don't know. I tried plugging a fan in here, and the fan just spins slowly. So yeah, I'm not quite sure what to do with this one. So the best thing I know to do is to send it back to the owner so he can put it back into the machine and test it, and then let me know whether it works or if it does the same thing again. Alright, so fast forward a little bit of time, and this Apple Network Server power supply, I sent the one I just fixed back to the original owner that had the new chip installed, and it worked fine. Even though I couldn't really test it on the bench, it worked fine at his place. No problems. And then he said, this is the second power supply. It was working. He recapped it. Now it doesn't work anymore. So now we got to find out what the issue there is. Now, while he had the power supply at his place hooked up and working, I had him take measurements of these sense wires and these control signals, so I know what they're supposed to be under test. So I was on the right track with having the sense positive line connected to this 3.3 volts and the sense negative connected to ground, and then the power on wire on off connected to ground as well. So that's all accurate. So the only wire I didn't have any information on was this overcurrent protection wire, which he told me what that is supposed to be. And it's supposed to be, this white wire is supposed to be 5.03 volts. This gray is 4.09. which is kind of weird. Green is 0.02, and then orange, which is the sense positive, is 3.42 volts when this power supply is running. So I'm trying to think of. I think that's it. Sorry, I'm looking in my list here. Um. Okay, so. All right, so in standby, gray. Yeah, okay. So the gray wire is not grounded all the way. It's down to like 4 volts or 3.8 volts or something like that, which is strange. I've got it grounded, so maybe it's not supposed to be, but this is supposed to be 5 volts according to the measurements that he took. Now, whether they're accurate or not, I don't know. But orange is 3.42, which makes sense because that's probably the current sense wire that's connected to here. So that's all good. Now, I have an electronic load that we're going to use to test this power supply to see what's going on with it. So let me get the electronic load set up so I can do a better test so I can see what's going on. I'm trying to figure out which power rail is the actual sense rail. We have a sense wire on 3.3 volts, so this thing may need a 3.3 volt load on it. It might be 3.3 volt, it might be 5 volt, it might be 12 volt. But what I'm getting down to is there is a sense rail that comes back that's the feedback that keeps everything regulated, and that's the rail that I need to load down so it doesn't go into shutdown. So, all right, yeah, let me get that figured out and we'll get this thing set up properly so we can work on the second power supply. All right, so I got my load tester hooked up, and I had to go back and double check again because it's been a little while since I fixed the last power supply. Now in this video it looks like I fixed it 5 seconds ago, but it's been weeks, maybe months. So anyways, now I double checked all my notes and I checked the measurements he got. So the trickle voltage and the power on signal have to be jumped together, so that makes sense to the 4 some odd volts. 3.43 on sense positive, 0 on sense negative, which makes sense because this is a 3.3 volt sense line. That's the ground sense line. So I had it right in the first power supply. So the reason why the first power supply wouldn't start up, it would just burst up and shut down, I don't know. Probably because I don't have the fans and stuff connected. There's probably protections. This one's doing the same thing. But here's the weird part. So I got back in touch with the owner, and he said this thing, it would turn on for like a half a split second and then shut right back off, which is exactly the behavior I've got going on here. So if I plug this in, it kind of bursts up and shuts down. And actually my current's too high. It doesn't even try. Yeah, it kind of gives me voltage and it shuts down. So, yeah, I think my protection is kicking in just like it was on the other power supply. I'm trying to figure out how to keep this thing satisfied. Now, since the sense wire is on the 3.3 volt rail, that's the rail that I have loaded. And according to the sticker, this rail, including the 5 volt rail, which is up here, is good for 25 amps. 12 volts, not as much, or something like that. But anyways, I'm going to go ahead and do an inspection of the board and see what we got going on. So, yeah, it's not firing up right now. I don't know why. It's some kind of protection. This thing's got to be satisfied a certain way. And not having the fans plugged in, I'm sure, is contributing to it because there's probably current sense resistors there. So anyways, this is an earlier revision power supply because it's got this wire here. Interesting. 1995. So let's see. Let's do some Solder joint inspections. Let's see what we got going on here. Nothing's immediately obvious. Got a bodge. Hold on, what's this? Is that broken? Oh yeah, look at that. Wow. Yeah, that'll do it. Well, we gotta fix that before we can go any further. Let's see. Is there anything else? Because that's the big concern with me, because he's already changed the capacitors on this board. He said the board was working fine, and he changed the caps, and that's when it quit. I think he bumped into this and broke it, and that's why. Let's see, what is that? That is a 7912, so that's the minus 12 volt regulator. If there's a feedback connected to that for like a more sophisticated power supplies have voltage monitoring. It'll monitor each and every rail, and if any of them go out or missing, it'll shut down. So that's a problem. So we need to take a look at that. Let's go ahead and get my things switched on, and we'll just solder that up real quick. I don't expect the behavior to change because I can't satisfy the condition that this thing needs to be able to run on the bench. I've only got a single supply load. I'd need, because this has 5 volts, 12 volts, and 3.3 master voltages, and then a negative 12. I'd have to have 4 electronic loads to get that thing to work right, plus I'd need 2 fans. So, yeah. So that's where we are right now. So, let's get this thing fixed. Alright, so I got it on. I got this patched up and it's working. So now have my 12 volts. We're satisfied there. 3.3, it's a little high, but it's also not loaded. And then we should have our 12 volts. Alright, so we're good. And that's my current settings. I took the positive sense jumper out. Got the enable, and then I got the ground sense connected, so we're good there. So this positive sense has to be a little bit higher than 3.3 in order to keep this thing satisfied. That's why I had a 3.43 management, or 3.43 measurement on the good system. So there we go. It's done. This power supply is fully operational, so we are good to go. And that's going to wrap this one up, ladies and gentlemen. If you have a comment, please feel free to leave one. Don't forget to hit the like and subscribe and all of that fun stuff. And thank you for watching. See you next time.